Miriam Ram Studio Lesson 1. This tutorial will describe how to make a rather simple model step by step as an introduction to Miriam Ram Studio users. After working through this tutorial, you will be able to build both simple and more complex models using this tool. The environment is extremely flexible, allowing you to dock and undock windows. Right-click a tab and select Float. You can now move the window to any part of the screen. When you click on the minimize icon of the window, it will minimize this to the side of the screen. Press on this again and it will dock the window back into the workspace. When pressing the maximize window icon, you can then drag the tab back into the docked group. The tool was built with the drawing area in the center, designed with input-output panels surrounding this, allowing you to manipulate the different diagram properties. Let's first familiarize ourselves with the main panels. Here we have the Studies window. This is where you can organize your portfolio, create or add a new model, share, delete, and export studies. You can also edit the study and model name in this area when it is currently selected in blue. Just click the study again to move to rename mode. This can also be changed in the Properties window as well. Studies can hold as many models as you want. The benefit of the studies is that models in the same study can share equipment definition. This window validates the model real-time and automatically displays the problems discovered in the network. More on this later on once we have entered the data. The right side contains more input panels, which will also be described later in full detail. Here we have the Throughputs panel, the Palette, and finally the Properties panel. Whatever elements are used and selected, such as the model, study, process stages, and so forth, this window will display the properties of that particular element. Most of the work will be done in this area. The network consists of process stages, shown as rectangles. It is one of the most intricate entries in Miriam Ram Studio. It can be thought of as an imaginary boundary inside the real system. A typical process stage consists of one or more identical parallel streams, which contain identical items, and thus the stage capacity equals the stream capacity times the number of streams. Next, we have the boundary points shown as triangles, which define the boundaries of the system. They also define the amount of each throughput that enters and leaves the system at all times throughout a system's lifetime. Next, we have the storage unit shown as a circle. These are important elements in real processes, both as a store and as a unit used to increase production availability. And finally, the pipelines, which are shown as diamonds. These are network elements introduced in the Miriam Ram Gas version of the Ram Studio. They allow you to model pipeline-specific features such as pressure-driven flow, line packing, and gas batches. More information about the pipeline and pressure will be given in a Miriam Ram Gas-specific lesson. All these elements are available from the Palette section. Start by creating a study. Press on the plus sign in the Studies window to create a new study. With the study currently selected in blue, click the study again and it should move to rename mode. The name can be changed as well in the Properties window. Then create a model in the study. Select the Models folder and right-click. Choose Add a new model or press Ctrl and N on your keyboard. To change the name of the model and give it a description, go to the Properties window, then type an entry. Next, press Tab to move to the next field and start typing. Drag an entry point element from the palette and drop it on the drawing board. Then add a discharge point. Notice that as you do this, errors are reported immediately by the tool's validation system. You can double-click on one of them to show the place in the property of the given element where we have the error. also take note of the red field in the Properties window, also a result of the on-the-fly validation system. This is linked with the messages in the Issues window, which reminds you to go back and enter required data. Then do the same for the process stages. The next step is to connect the elements together with links. The elements added in the design sheet must be connected with links. Each process stage and storage unit must be connected to the network by at least 2 links, one upstream and one downstream. Entry points must have a downstream link, and discharge points must have an upstream link. The number of upstream or downstream links, however, may be more than one. Create links between the elements by moving the pointer over the side of the element to display the connection handle. When you click on the connection handle and start moving the mouse, the next element will also display a connection handle. Simply drop the end of the arrow on the handle of that element. Change the names through the Property window. When one element is dragged to another location on the drawing board, its link will automatically route to the next element. Select all the elements by drawing a square and move the selected group on the drawing board. Use the zoom functions to zoom in, zoom out, fit to view, and fit 100%. Select the Navigator panel to display the logical view, and click on the elements in the tree to highlight these in the drawing area. Then switch to Satellite View and move the drawing view, or the gray rectangle, over the drawing board and see the effect on the drawing area. To show the editor options, go to the Tools menu, select Options, and in the Options window, click on Miscellaneous, then select the Editor Options tab. For example, click on Show Grid as Lines and set the size to 15. Then select Snap to Vertices, then click on OK to close the window. Try moving some elements and get them aligned using the vertices. Now that our model is on the drawing board, you can go back to the Issues window and check the requirements calculated from the flow through the network. This will be demonstrated in the next lesson. For now, let's save the model. Changing the focus, saving manually by clicking on the Save icon in the toolbar, or leaving the program is needed to trigger saving. This will store it in the secured user's workspace on our servers. Thanks for watching the first lesson on the main window and flow diagrams using Miriam Studio. Check out our website at www.miriamramstudio.com.